Welcome everyone to our lesson on quadratic inequalities. So today I'm going to show you the best possible way to solve all your quadratic inequalities. So stay tuned and pick your pencil, papers, and let's work this through. Right, so the first question that we've been given is here. We have x plus 3 and then x minus 4 is greater than 0. Ideally, you would want to just solve it straight away by saying that this is greater than 0 or that is greater than 0, which will give you x is greater than negative 3 or x is greater than 4. Okay, so this is what you would do, but the problem is that these answers are not true. Why? Well, let's do a check and see. We are saying that x should be greater than negative 3, right? So we could choose an x value such as negative 2. Now, when we put negative 2 back into this equation, the answer should be positive. It should be greater than 0, isn't it? So let's give it a try. So we have x plus 3, and then we have x minus 4. We chose x to be negative 2. So we have negative 2 plus 3, and then negative 2 minus 4. So this will be 1, and that will be negative 6, which will give us negative 6. Is negative 6 greater than 0? Sorry, the answer is no. It's not. So, that means we are wrong over there. So let's check the other one too. We say x is greater than 4. So we can choose x to be what? 5, right? Cool. So you have x plus 3, x minus 4. So 5 plus 3, and then we have 5 minus 4. This is 8 into 1, and that is 8. Is it greater than 0? The answer is yes. So 1 is wrong, 1 is right. The question is, why? So do we always have to get one wrong, one right? Well, the thing is that we have a better way that will always give you the right answers. Okay? So that's what we are going to study today. So what you actually want to do is to sketch the quadratic. And curve sketching is so easy. You don't even have to be perfect. No. All you need is, one, you need what we call the x-intercept. Okay? You need the x-intercept, and then you need the y-intercept. That's all. Okay? And then you are good to go. Of course, I know some of you are thinking, how about the turning point? Well, you might need a turning point if the question itself is about sketching a curve, okay? But the issue is that we are not asked to sketch a curve. We are just sketching the curve to help us determine the desirable region. So, these two will be enough. But if you want to add the turning point to, good for you, okay? So the first question, I'm going to add a turning point, just so maybe you guys want to sketch with a turning point. Then the subsequent ones, I will just work with the x-axis and then the y-axis, then I'm done, okay? So let's see how that will go. Remember that the question is x plus 3, x minus 4 is greater than 0. So we look for the let's start with the y-intercept, okay? Looking for the y-intercept. At the y-intercept, we say that x is what? 0, right? Good. So we have 0 plus 3, and then we have 0 minus 4. And that would be 3 into negative 4, giving us negative 12. So we have 0, negative 12. So this is the point on the y-intercept. Now the x-intercept. For the x-intercept, you equate what you have to zeros. It means we have x plus 3 and then x minus 4 equals 0. So x plus 3 equals 0 or x minus 4 equals 0. So we have x equals negative 3 or x equals 4, which means we have these points, okay, on the x-intercept. Right. Then we might want to talk about a turning point. I said for this question, I'll deal with the turning point just for you. Okay. Now, the turning point, this is what you do. You come to the x-intercept. You got two values, x equals negative 3 and then x equals 4. What you do is that you add those values up and then you divide by 2, okay? So you find the midpoint of it. So the x-coordinate of the turning point will be negative 3 plus 4 over 2, and that will be half, okay? Or 0.5 if you want. Then what you do is that you put that value into the equation they gave you. Okay, so you have half plus 3, and then half minus 4. And then when you multiply this, what do you have? Okay, so that's 3.5 times negative 3.5, right? So that's negative 12.25. Okay, so it means the turning point is actually half and the negative 12.25. All right, sorry. Okay, so this is what you have. All right, now we go and sketch. So let's sketch it. All right, so let's use red to sketch. I like red because it stands out. Okay, so, all right. So this is X and that is Y. All right, so let's sketch. Now we said that the X-axis, we had negative 3 and then we had 4. And then the turning point is around half. Let's say this is half. Okay, and then the is half and then negative 12.5. So let me extend this a little bit. Okay, so this is, let's say this is negative 12.5.25. Okay, so the turning point, we expect it to turn around this point. Well, and then we also said that the y-intercept, okay, is negative 12, which is, let's say this is negative 12. All right, so we are going to sketch our curve like this. I think we are having a little bit of a challenge here. So let me just sketch straight away, and then we would add the intercept. Okay, so this is the turning point. All right. Okay, so we can say that this is the negative 12. Okay, that's the y-intercept. Anyways, now the question says that this curve should be positive. All right, now this is the deal. All the parts that is below the x-axis, that part we call the negative part, okay, is the negative. And all the part that is above the x-axis, that is the positive. So this is the positive. Okay, it's positive. And all this part is also positive. Good. So now, if we want to get the positive version of this curve, then it means we should be going this way, isn't it? Or we should be going that way. That will give us positive. But if we come here, we would be coming to the negative region. And if we come back, we come into the negative region. All right. So what are the values that increases the curve at this point? Well, that means x should be less than negative 3. Okay? Because when x is less than negative 3, you're coming to negative 4, you come to negative 5, the curve will be increasing here, having a positive. And this side, okay, this side, we expect x to be greater than 4. If x is greater than 4, then we'll be getting positive values, okay? So that's the point. So for you to get a positive value, x should be less than negative 3 and x should be greater than 4. So we have x is less than negative 3 or x is greater than 4. That is what you are looking for. And this is the solution. So like I said, you sketch it and then the curve will tell you what to actually do. Okay, because you are looking for a positive, so the curve will tell you. But if we are to solve it algebraically, like what we did here, there will be a problem. Look, what did we get? X is greater than negative 3. All right, and then x is greater than 4. Well, we saw that x is greater than 4 was true. However, this was not true. Now, when you come to the curve, you could see that it was the other way around. Rather, x is less than negative 3. So always sketch and you'll be fine. Let's look at the second example. So this is what we have. Now, the first one, what I did was that I factorized it for us. But right now, we are rather going to factorize it, okay? Now, when you have a quadratic, the clue is that what are the values, okay? That is, there's a 1 here, and this is negative 14. So when you multiply, you have negative 14, Okay, so you are looking for the factors of negative 14. When you add, you get 5. That's the deal. You add the factors, this is what you should get. Okay, so come on, let's see this. Just open the two brackets. It's less than 0, right? This is x, that is x. So what numbers are you working with? You are working with 7 and then negative 2. So because 7 times negative 2 will give you negative 14. Okay, if this is the case, then like I said, the x-intercept will mean that you equate them to 0. Okay. Sorry. Oh. All right. So this plus 7, this 2 equals 0. So you have x equals negative 7, and then you have x equals 2. Okay. Then you can decide to, this is your y-intercept. Okay. You don't need to look for the y-intercept. You can just see it from the question. All right. So let's just go and sketch it. Okay. So we have something like this. Okay, we have something like that. This is x, that is y. This is negative 7. This is 2. So we can sketch it like that. Okay, so that will be negative 14. What is the question saying? The question says that it should be what? Less than 0. It means it must be negative. And if it must be negative, then this is the region that we are interested in. Okay, this is the region. The part that is below the x-axis, that is the negative part that we are looking for. Now, how do we get this? Well, this negative portion, it means that x should be more than negative 7, so we can come back, right? Good. So x is greater than negative 7. How about this? S must be less than 2, okay? So that we come back to this negative region. So we have, let me expand, good. So we have x is greater than negative 7, and then we have x is less than 2. Can we put this together? Let me see. So you have x is less than 2, then x is greater than negative 7. Yeah, so you can put the two together to become nice like this. That's also fine, right? So these are the solution, the true solution. So when you sketch, you see, when you sketch, it's easier. So easy. All right, let's